QuantConnect Bootcamp 101, U.S. Equities. Learn algorithmic trading with Python for U.S. equities. Guided strategy development in easily digestible portions. Going to be using C# instead of Python, as eventually local debugging is going to be easier in C#. Also, back testing is significantly faster, and the lean code base is predominantly C#, so being familiar with C# opens the opportunity to contribute. Lesson 1. Buy and hold equities. Learn how to initialize an algorithm's backtesting date range and starting portfolio value. You'll be able to request U.S. equity data and configure the resolution of the data. We'll explore 2 different normalization techniques, raw and normalized, for adjusting the data delivered to your algorithm. You can watch the video here. Jared is a very likable character, and he is the main educator of this course. Setting starting cache. Initializing algorithms. At the very start of your algorithm, we call the initialize method to set up your strategy. It is important to set up the state of your algorithm here so it can be restarted easily. Initializing cache. The set cache method sets the starting capital for your strategy. In backtesting, we use the value you set to initialize your capital. In live trading, we get this value from your brokerage account. By default, we use a starting cache of 100,000 in backtesting and paper trading. Task. Set starting cache for the algorithm to 25,000. Let's come here, do set cache 25,000. You can also look at the solution or show hint and see the solution. And you can toggle between the solution and the main. And you can copy paste. You can copy this entire solution into the main and paste and submit. Submit. I don't know what this grid type is not valid issue is. Next. Set task range. Initializing analysis dates. The date range for your backtest is defined in your initialize method. You can set this with fixed dates or a datetime object. These methods are called set start date and set end date. Task. Set the start date for the backtest to January 1st, 2017. And set the ending date for the backtest to October 31st, 2017. Manually selecting data. Initializing data feeds. There are many ways to request data in QuantConnect. To start, we're going to demonstrate how to ask for data manually. Adding data. The add equity method is used for manually requesting assets. It takes a string ticker of the current asset name and the resolution. For more information, see the documentation. The add equity and all other add asset methods return a security object. This gives you a reference to the security object you can use later. You can control the resolution of the data with the resolution enum. It has the values tick, second, minute, hour, and daily, e.g. resolution.minute. Not all data is available in all resolutions. To make sure your resolution is available, see resolutions. You can change leverage, request pre-market data, and disable fill forward. You can see the API calls in the documentation. We'll discuss these next. Task. Update the code to request minute resolution data for SPY. So here we have add equity SPY. It's currently in the data resolution. Let's change it to minute. And then add minute resolution data for IWM. So let's add equity IWM resolution.minute. It does this sometimes and doesn't have very good debugging. Sometimes I have to refresh. Then I go to solution. Looks like the solution is the same. Oh, I added a main.cs on accident. Main, submit. Set data normalization mode. Data normalization. In QuantConnect, historical data is adjusted by default. This means the historical values are changed to account for share splits and dividend payments. Historical prices can look a little bit strange if you don't understand why it was done. E.g., instead of $10.23, the price might read $1.21 and decimal cents. To set the data normalization mode for each asset individually, pass a data normalization mode argument to the add equity method. The accepted values are raw, adjusted, split adjusted, and total return. Here they have an example. IBM is add equity, IBM resolution minute, and then the data normalization mode adjusted. Accessing securities. Securities in your algorithm can be accessed via the securities dictionary. It looks up a security by its symbol object or ticker string. Using this accessor, you can look up a security and alter its models or data normalization mode. As an example, securities, the key of IBM, and then you can set the data normalization mode here. Task. Change the data normalization mode of SPY to raw. So let's do data normalization mode. Instead of adjusted, we'll do raw, not raws. And then do leverage 1.0 thing. Great. Checking holdings. Oh, I should have gone back and said the task. Set the leverage for the IWM equity to 1.0. And that's this right here. Checking holdings. Global portfolio properties. The algorithm portfolio dictionary also has helper properties for quick lookups of things like invested, total unrealized profit, total portfolio value, total margin used. You can see more properties in the documentation. Example, if portfolio invested, debug total unrealized profit plus portfolio dot total unrealized profit. Specific portfolio items. Individual asset holdings are held in your portfolio property. This can be accessed via the portfolio symbol dictionary. Entries in the portfolio dictionary are security holding objects with many properties about your holdings, such as invested, quantity, average price, and unrealized profit. Example, if portfolio IBM invested, debug, we have IBM shares. Task, update the add equity command to request IBM data instead of SPY. Fix the compiler error on the debug statement to display the quantity of IBM shares you own. Placing orders. In this task, we're going to pull together everything we've learned so far: requesting data, setting data normalization, using your portfolio, and printing a debug statement. Submitting an order. Let's place our first trade. There are many ways to submit orders through Lean, but we're going to start with a market order. It can be used like this: market order for Apple 200. Market orders are filled immediately when the market is open. If you use daily data, the order isn't processed until the next morning. Daily bars only arrive at your algorithm after the market has closed. Fill prices. The average fill price of your asset is available in the portfolio class. You can access it like this: portfolio IBM average price. In backtesting, this is a modeled price. In live trading, this is taken from your brokerage fill event. Task. Insert add equity and initialize in the initialize method to request IWM data at the minute resolution. So add equity, IWM, resolution.minute. And then in the on data method, place a market order for 100 shares of IWM. Using the debug function, print the average price of IWM to the console. Oh. Let's use this right here. Hmm. Oh. I missed this part of the task. That's it for lesson 1.